Okay, everyone, we're going to move on to the sine ratio now. Now, we've just finished the tan ratio. The tan ratio will look just like this. I'm going to write it down here. And the tan ratio was tan theta, or tan of an angle, is opposite over adjacent. Now, in that lesson, remember, we looked at finding sides. And there was two situations based on where the x or unknown was. And then there was finding angles. Well, that was tan. And tan, remember, that was the relationship between opposite and adjacent. Well, in this lesson, which is the sine ratio, essentially we're doing the same type of calculations, just this time we are relating different sides. So long story short, if you understood how to figure out the tan ratio and all those calculations, you will find this to be quite easy. With that said, the tan ratio lesson was quite more in-depth because that set the stage for all the other calculations. That will allow me to go through the sine ratio calculations much faster. So I'm going to kind of assume at this point in time that you were successful with the tan ratio lesson. I'm just going to go through some basic examples and we'll go from there. So what does the sine ratio look like? The formula looks like this. You have sine theta, or sine of an angle. This time it is opposite over hypotenuse. So nothing has really changed here, everyone. I'll draw a right angle triangle. Looks like this. Remember, you'll have your hypotenuse. Now, it's the same thing. So what I'm going to do is I'm going to give us a basic angle. I'll put in 25 degrees. And what's going to happen in this case is we're going to be working with, remember, you can always name your sides. Remember, this points to the hypotenuse. Then we look at our reference angle, and this would be the opposite of your reference angle is your opposite. By default, this side is adjacent. When we deal with the sine ratio, we are dealing with the opposite side and the hypotenuse side. Okay, let's move on to some calculations, because you see, it becomes repetitive after a while. Okay, so we're going to go here, finding a missing side. And just like with the cosine law, there's two ways of doing this. So, or not two ways of doing it, there are two places where you may find the x. So what I'm going to do is I'll draw us a right angle triangle. There's our 90. I'll put this as 30. I'm going to put this as our x, or our unknown, and I'll just put this as 15, let's say. So remember, the first step is always to name your sides. Always name your sides. You have to do that. I'm going to start doing this faster because I'm going to assume that you follow along with these lessons. That's my opposite. This is my adjacent. Okay, so name your sides. Number 2, fill in your formula. So the sine ratio formula looks like this. I'll show it to you again. Sine theta equals opposite over hypotenuse. So in this case, it's sine, the value of our angle is 30. Our opposite we do not know, so we'll put x over. Our hypotenuse value is 15. Also now, to calculate this is the exact same as the tan ratio, just this time we're hitting sine, or SIN, that button on your calculator instead. So, and remember, I've also included now the video for the scientific calculator via Google Chrome. So I'm kind of going that we have a standard way of typing this in. So here we go. What am I going to do? If you remember from the tan ratio, because our x is on the top, we are simply going to multiply these two values. So with my calculator in degrees, I'm simply going to hit the sine, or sin button. It means sine. So I hit that. A bracket comes up. I'm going to fill in 30. I'm going to close the bracket. I'm going to hit multiply by 15 because that's this multiplication right here. And it is going to give me, so sine, I'm going to type in sine 30, close bracket, times 15. And that gives me 7.5. So that missing side is 7.5. Let's do one more since we've done a lot of these in the tan ratio already. Okay, I'll draw this one out. Okay, so let's make this one 20 degrees. Let's put the x right there, and let's make this 45. Okay, so what you have to do, as always, is you have to name your sides. So that will be hypotenuse, this will be your opposite, and this by default will be your adjacent. Then what we're going to do is we're going to use our formula. So that's going to be sine, I'll do it a few more times here, opposite over hypotenuse. That's going to look like sine 20, 20 is our reference angle, x over 45. Those are my values for opposite and hypotenuse. I am simply going to be going to my scientific calculator. I'm going to hit the sine button, 20 close bracket multiplied by 45, and that gives me 15.39. Okay? Now what you'll notice is, just like with the tan ratio, in these last two examples, our unknown was in the top of the fraction or the numerator. So you should now know what's going to happen in the next two examples that I show you. This time I'll draw a triangle, and I'm going to force the unknown to go onto the denominator. So let's make this 10 degrees. I'm going to say that this is 25, and I want to know the hypotenuse, or the x value. Right now, no matter what happens, we should know that our x value is going to be greater than 25. How do we know that? The reason we know that is the hypotenuse is always along the side of a triangle. So if by some chance this calculation comes out to be, let's say, 14, we know we've done something really wrong. So the first step is to name your sides. So this is going to be your hypotenuse, this is your opposite of the reference angle, and that's your adjacent. Use your formula, which is number 2. So sine O over H, sine 10 equals 25 over our hypotenuse value. Please remember from the tan lesson, how do you calculate this? What you do is you take that 25 and you divide it by the sine 10 value. That only occurs when your x value is in the denominator or the bottom of the fraction. So you type it in basically straightforward. You're going to go 25, hit the divide button. Now hit the sine button, 10, close bracket. It gives me 143.96. And it is nice to know that our hypotenuse value is definitely longer in this case. I'll do one more example for you. Okay, we'll put this as, 13. We'll make this one 5, and we want to know that. So number 1 is your sides. Always name your sides. This is your hypotenuse. This is your opposite. This is your adjacent. Sine equals O over H. So that's going to become sine 13 equals 5 over X. The calculation becomes, because our unknown is in the denominator, is 5 divided by sine 13. And that's going to give us a grand total of, oops, I missed hitting the sine button, sine 13, 22.23, I guess. Okay, there you go. Now, if you pay attention to the tan lesson, we've done the two sides, the two ways of finding a side. You should know what comes next, and that is the angle. So now we're going to look at finding an angle. The one thing I should say here, when we find an angle, is remember that's where your button comes in. There's either a second function button, or there might be a inverse function, or it might be a shift button. It depends on the calculator. If you are using the Google Scientific Calendar, I believe the button we're looking for is the inverse. Anyway, though, everything's going to remain the same. It's just a difference of hitting one button, and this time we're solving for an angle. And you'll tell, I'm going pretty quick through this, but I think that's okay because, like I said, if you figured out the tan method, this is no different. So I'll draw an example. Okay, and this time we want this angle right here. I will give you, this is a value of 13. I'll give you a value of 18 right there. Find that angle. So number one, name your sides, always. So this will be your hypotenuse. This will be your opposite. This will be your adjacent. 2, use the formula. So in this case, you're going to go, so this is the base formula. Fill it in, that's sine. We are looking for this angle this time. We have both of our opposite and adjacent values, or opposite and hypotenuse. So remember, I'm going to tell you exactly how to figure this out. What you're going to do on your scientific calculator is the first thing you do is you hit the inverse button. Then you hit the sine button, and that has a bracket now. You simply type in 13 divided by 18, close the bracket. You should get about 46.24 degrees. Exact same method as the tan ratio. We'll do one more. We want that angle right there. This one will be, let's say, 9. This one can be 22. Number one is name your sides. So this will be hypotenuse, opposite, adjacent. Number 2 is formula, and then you solve it. So it's going to be sine of your angle is O over H. Sine theta, we are looking for this angle, equals 9 over 22. If you're using the Google Calendar there, or sorry, not Google Calendar, Google Calculator, you're going to hit the inverse button, then hit sine, then simply type in 9 divided by 22, close bracket. I got 24.15. There you go. So really, I'm not sure if too much was new in this lesson. Maybe the only thing that was new is which two sides make up the sine ratio. It's opposite and adjacent. So like I said, in conclusion here, this is our new formula. Sine is the relationship of our opposite over hypotenuse side. What we looked at is how to find sides. And if you think of that, there really were two ways. Remember, they look like this. One of them looks like this, where our unknown's in the top, in the numerator. The other one is when the unknown is in the denominator. And you're expected to know how to do both of those. Number 2 is when you're supposed to find an angle using the sine ratio. And that's totally fine. It looks something like this, where you have sine theta, or they'll put some variable there, but you're trying to solve for this. You want your angle, and that's O over H. And you have to know how to use the sine ratio to figure out those formulas, or those values. And we will give you practice on that. Again, if anything here was totally unclear, you might want to go back to the tan ratio lesson where it was covered in a little more depth.